mean, in the end, a computer will free it, will have to free it, but programming languages exist for a reason. And the reason is that writing raw machine code is ugly and extremely complicated to do. So programming languages exist to make programming easier for us, so that we don't have to write every single detail of our code. But if we have to write every single free instruction by hand, this is actually something that we try to avoid, right? Because otherwise, we are doing maintenance and bookkeeping that we have already solved using this. We don't care about the bookkeeping, what happens like when we call the close function on a file descriptor. We don't need to care what it does. If it spins down the disk or does some other internal operating system code, we don't care, we just say close. For this one, we'd have to like free everything, although we don't have to. I mean, it might be a bit nebulous what I'm talking about, but I'm going to get to the point here. Do you get the rough idea on what this approach is and how it solves this problem? Again, you read blocks, you don't know what these blocks contain because they have to be a fixed size. That's what the exercise says. You get the number, and then these blocks are fixed size, period. Now, these blocks can contain a complete line, but they don't have to. They might contain a portion, they might contain something longer than a line. If that happens, you need some kind of memory space to store the temporary data. Now the problem is, well, if we have something like this, a string, we basically abuse the string data structure to store this data here. Strings weren't made to be created and then cut down again, created and cut down, because if actually they were made for this, the C language would have much stronger support for strings where we don't have to do. Like, if joining and splitting strings really was part of C, we could be doing this, because again, C was invented to make things easy for us. If this is hard, then C wasn't made for this approach. Therefore, we need a different approach, and there is one, luckily. Okay, so you get the idea of that. Yes, everyone? Cool. I'm going to clear that off, and then we're going to look at a different approach. And again, this is what I was trying to say with this diagram. Either you have your problem, that's a pretty wonderful P, problem, and you cram it down into the C language, like here. Well, the C language has a char pointer for data, so I'm going to use the char pointer to store this data. It will work somehow. I mean, we need some kind of black magic with the freeing and cutting and splitting, but in the end, it works. We can hack things together, right? No. Because this will lead to excruciating pain when something goes wrong. If you miss one free statement, you have one allocation, two allocations, three allocations. If you miss one free statement, and your code is completely filled and bustling with mallocs and frees, STR joins, every programmer, regardless of how experienced they are going to lose track on what's happening. They're going to lose track on what the data actually, when it gets created, when it has to be freed, which one gets returned, which one is going to be freed here. This one is, this one isn't. You have to keep that in mind when you write code like this, and it's going to hurt. So getting better at C doesn't work if you cram everything into what the C language provides you natively. This is the native thing. The idea is to work the other way around, building C into your problem domain by adding layers upon layers around the C language, and therefore making it easier to do such things without having to go into this approach again. Just like file descriptors did the same thing, we can build on top of that too. Okay, this is the abstract part on how to solve things. Let's get concrete here. And I think this is why getNextLine is actually a pretty neat exercise if you know about objects. If you don't, it actually teaches you the wrong thing. Because if you don't know about objects, it teaches you how excruciatingly painful debugging memory leaks is. If you know about objects before you start getNextLine, it's going to tell you a lot about how to use objects and how to break down problems the other way around.
Yeah, because I'm still in Liberty, so I have...
Then you have the best to come now.
Could I wasted just my whole last week on C, getNextLine,
Yeah,
trying to
so-
cram that problem into C.
But I think you might be getting what I mean with excruciating pain. Because debugging sessions that stretch into the night are not fun. seriously not. And this is just get next line. When you are actually a fully trained programmer, you're going to have to deal with much more complex tasks, like writing operating systems themselves. You cannot pass that just by using things like strjoin and char pointers all over the place. You have to build your own. Like, this is actually a pretty important thing. And this is not only because why not, this is basically my motto when I code. I see basically the entirety of programming as some kind of a playground where you can basically have your own little objects. To me, programming is a lot like magic. You have your own structures and objects, and you can manipulate them. You can stretch them, thin them out, I don't know, just like geometry. You can make them taller, longer, you can stretch them to whatever you like. If you only had this block and you built everything out of these blocks, you might be building Minecraft or something, but in the end, you are stuck with this block. If you have the feature of combining things, you might be putting these together to form something like, well, that. So what I mean is objects can like click into each other and build more complex objects out of pretty simple ones. If you only have this one, you might be building some kind of blocky house here, but in the end, you're not going to be too happy with that.
Is this solar?
Kind of. Yeah,
So
I'm actually planning on building a Minecraft clone here. No, of course not. But what I'm now aiming towards is we are now going to solve get next line almost in its entirety by reducing its complexity.
So you believe that, like, generally in all programming, we should like look into how we can like view the problem as objects and how we can like.
Kind of. Objects are one way. Objects are basically my tool that I use to teach you the concept of abstraction. Basically, objects are just one approach to build layers around this programming language. There are languages like Haskell or Lisp, which are functional languages mostly. And in these, you can actually build everything out of functions. You don't need objects there because you can even build objects out of functions. And functions are basically just there in the system. C has functions, but not in the way that the other languages have. So in the end, objects are just one way to your goal. But in C, objects are the way to go because C is not as complex as these other languages in its feature set. C is very close to the metal, to the hardware, and since that's the case, objects are the best way to represent things, or one way to represent them. Other languages give you different abilities, and of course this is why I'm going to do a lecture on languages like these two. But for today, let's stick to objects. Okay, so the task again was to write our getNextLine function. Okay, again, I might be crossing out this int because we don't care what default descriptor is. This is the important part. We don't care how it's implemented. Okay. Why do we even have getNextLine? Have you ever thought about that? Apart from, well, it's a mandatory part of the 42 curriculum. Have you ever thought about why getNextLine might be useful? Or in what context you might use it?
Like when you type an enter, like
yeah.
When
so reading line by line basically. So what you have is, remember when I told you that objects are basically whatever we think about them. Like the number 42 can be encoded as binary stuff, or it could be something entirely different. It all depends on how we talk about them, what they can do and what they are. Everything what they can do and what they are depends on how we talk about them. So therefore, we can look at files either as strings, or if we just say, well, a file is basically a one-dimensional set of bytes, but the \n makes it two-dimensional by adding a new line. This is just a convention. We could also be splitting on the character E for new lines, and \n is a normal character. We don't care. Again, it's all what we design it to be. To the system, it's just going to be a string of bytes. Again, just zeros and ones. Until eternity. It's what we make out of it. So we treat this by convention as a two-dimensional file. that we can split into these. Again, the computer doesn't care. These lines can have different lengths, of course, and all end with the \n, just to clarify that. The last one might not, but it could. So what's the idea here? getNextLine will basically take a file descriptor and instead of like the read function gives us back a single buffered block. The read function will give us back this one-dimensional thing. The getNextLine function will eliminate this block reading part and get us directly to the more abstract. Again, this is basically getting more abstract. Far away from the zeros and ones, further away from the hardware. Again, building layers upon layers. Here's the zeros and ones, here's the C language, or maybe machine language. Here's the assembly language. Around that is the C language, around that is file descriptors, and now around that we build our getNextLine. And every single layer adds complexity. Here you have like circuits, zeros and ones, literally, electronics. Here you have machine language, still zeros and ones. Instructions like move this byte from here to there, move this 8 bytes from here to there. Assembly language is the same as this, but in a way that people can read and write. Some kind of programming language that makes it easier. It's not zeros and ones, but it's still very close to the hardware. C gives us functions on top of that, and structs that assembly doesn't really have, apart from 1 or 2 assemblers. File descriptors are built on top of C's structs and integers, which are going to provide you with one-dimensional files. But if we have two-dimensional files, one-dimensional files are good for binary data, but very bad for this. So if we have two-dimensional files, we're adding the second dimension now, using the getNextLine, which is going to take this and get out these lines now. Okay, but now the question is, can we build on top of that? Yes, we can. Or basically, there is a layer in between. We have the getNextLine here. In between there is something, which is what I'm going to call getNextChar. If we can write a getNextLine that gets the next line from a file descriptor, why can't we also write again? Because why not? Imagine things. Playground. If we can build a getNextLine, well, getNext